Now let's have a look at 2017 question 9 part A. This is another one of our weird sphere questions floating in a bit of water. In this case, a little bit of a twist. We need to find out the volume of the iron bit sitting inside the big ball of ice. Okay, well, let's have a look at what we know in this one. The total volume is equal to the volume of ice plus the volume of the iron. And that equals 4 over 3 pi r cubed. Okay, so we'll probably use this one along the way somewhere. The other thing we know is that it floats. So the buoyancy equals the weight. There's no apparent weight, it's not going up, it's stable. All right, so let's see, can we begin to unpick this one a little bit? Well, the buoyancy is to do with the amount of water, the amount of the ball in the water. So it tells us there that that's 95%. All right, and the buoyancy force, of course, is the volume, density of the water by g. Okay, that equals the weight, which again, if we use the weight equals v rho g, it is the volume of the ice by the density of the ice by g plus the volume of the iron, density of the iron by g. All right, at this point, let's say goodbye to our good friend G. It's been nice knowing you. Go away now. All right, what can we do in this one? This is what we're trying to get at. So I want this as my one variable. I don't want that there. So a little bit of rearranging will sort that out. We'll begin to drop a few terms in the next time around. So we have 0.95. The volume is 4/3 pi r cubed. Density of water is 1,000, which you should know, but they tell you anyway, just in case. That is the volume of the ice. Now, we'll do this the next time around, not to make things too complicated. So we'll leave it there for the moment. Density of the ice is 918. They tell us that in the question. G is gone, plus the volume of the iron, which is what we want to know, so that's going to stay the way it is, by the density of the iron by 7,800. And G is gone. Okay, not too horrible, but don't worry, there's a little bit of fun to come here. We need to get rid of the volume of the ice. So let's see what we can say on that one. I'll tidy this up a bit as I go. Again, not making too many changes each time around in order to avoid a bit of a silly slip. But that does become 0.001, and you can see where that's going to go with 1,000, but we'll deal with that next time around. Volume of the ice. Bring that across. That is 4 over 3 pi cubed minus the volume of the iron. Okay, we'll put that in a nice big bracket there because it's all by 918. So the volume of the ice has now been swapped out for that equation, which came from up here. And of course we have 7,800 times the volume of the iron. I just like to put the number in front where I can. Okay, well, that's going to tidy up so that we have 0.95 by 4 over 3 times pi. That's gone because 0.001 by 1,000 is 1. And now let's have a look at this bit of fun here. We will have 918 by 4 over 3 by pi by 0.001. This bit by pi minus 918 volume of the iron plus 7,800 volume of the iron. Now at this point I'm in good shape. I have one unknown, a bit of ugly maths, we'll sort all that out, so this is solvable. Happy days. This one across here, these two are going to combine together. So we have 4 over 3 times pi. We'll combine these two. 0.95, which is this guy, minus 0.918. 0.918. 918 by 0.001, and the 4 over 3 pi is common. All right, and that comes out, if you do it on your calculator, 6,882 with the volume of the iron. Okay, getting there now. we have 4 over 3 by pi. We'll tidy this one up, 0.95 minus 0.918, just in case you're under a little bit of pressure in an exam. A bit of a habit, get into just use your calculator for these ones, 0.918, and that is 0.032. 0.32 equals 6,882 volume of iron. Bring this guy across, so we have 4 over 3 by 0.032. Watch the small stuff. By 1 over 6,882. And by pi is the volume of the iron. Okay, a little bit of fun there, but let's just put this one into our calculator and see what it comes out to. So we have 4 over 3 by 0.032 pi divided by 6,882. Equals 0.00001947. Well, that's of course meters cubed. Now that looks a little bit horrible, so let's tidy that up. We put into scientific notation, which can be done the easy way or the hard way. You can count all the zeros and move it across if you like, but you can also do this on your calculator. It's worth knowing how to do this, but on my calculator, if I go to Setup, FSE, Scientific Notation, 3 significant figures, I get 1.95 by 10 to minus 5 meters cubed. Ta-da!